Complete analysis of multiple choice question exam quality in Excel. Using item analysis to evaluate and assess the quality of multiple choice question exam paper. Whether you are a teacher at a school or a lecturer at a college or an assistant professor or a professor at a higher education or university, and you are involved in designing and writing and editing exams that consist of multiple choice questions, and you want to evaluate the quality of the test and whether it follows a high standards, then this video will show you how to assess the overall quality of the test and then assess and evaluate each individual item or question within the test. There are 4 major analyses that can be used to assist in evaluation of a test or an exam that consists of multiple choice question. The first one is the reliability test. This test will measure the internal consistency of items, whether the whole exam stands, all the questions and the exam stands up as a reliable, i.e. if the same questions being repeated again in different days and different time with the same student, their score will be similar, i.e. the exam is reliable. And this can be assessed through using 2 analyses. The first one is the Couders-Richardson 20 formula. The second one is the Cronbach's alpha equation. And then the second analysis that can be performed to assist and determine which question is good and which question is bad, which question can distinguish between high performing student and low performing student. An item discrimination, abbreviated ID, will be used to analyze the test. 2 methods will be described and shown in this video. The first one is the Achilles Equation method, which is a mathematical method. The second one is a statistical method, which is a point biserial correlation coefficient. The third analysis will examine the difficulty of the exam. In fact, the difficulty of each individual question by calculating the p-value, the proportion value or the percentage value for each question, and to determine whether the question is easy or hard. And the final analysis is the item distractor. The distractor is the incorrect answer options in a multiple choice question. And the test will evaluate each distractor and determine which distractor is functional and effective and can distract the student from selecting the correct answer and attracting them to select the wrong answer. 2 methods will be described. The first one, the percentage method or the proportion method. The second one is the item discrimination method. All these analyses will be shown and performed in Excel step by step using an example of a data taking from a multiple choice question test. Here in this sheet, I had inserted result of an exam, a multiple choice question exam that consisted of 15 multiple choice questions from 1 to 15, and each question has 4 possible answer options: A, B, C, D. A correct answer for each question is highlighted and coded with a light orange. For question number 1, option B is the correct answer. For question number 2, option B is the correct answer. For question number 3, option A is the correct answer. When a student answers the question correctly, a value of 1 is inserted in the cell here. When the student answers the question incorrectly, a 0 score is placed in this cell. And as we can see here, for student number 1, he answered the first question correctly. So by selecting the option P, a value of 1 is inserted. Student number 2 had selected the wrong option, the wrong answer, so a 0 value is inserted, and the option that's selected by the student is given a 0 score. And these options are the distractor. So for question number 1, option A, option C, option D are the distractors. So there are 25 students had participated in this exam that had multiple choice question in it. And to evaluate the quality of this test and to determine whether it is of a high standard, then we are going to do an item analysis, all the component of the item analysis. We're going to determine the reliability of the test using the KR20, Coder-Richardson 20, reliability test using the alpha, and then we're going to determine the item to perform an analysis on the item discrimination and to determine the ID for each individual question using the Kelley's equation method as given here. And then we move to again an item discrimination using a point pi serial correlation using this equation associated with the table here as shown. And then we're going also to determine the difficulty of each question by calculating the proportion value. And we're also going to assess and evaluate the distractor, whether these distractors are functional or not, by doing 2 tests. The first one is the p-value and the second one is the item discrimination. And I will show you all these tests step by step in this video. To determine the reliability of this exam, we are going to use the Coder-Richardson 20 formula, that is equal to K divided by K minus 1. K stands for the number of the multiple choice question in an exam, multiplied by 1 minus the sum of P multiplied by Q divided by the variance. P stands for the proportion of the student who answered the question correctly, and Q stands for the proportion of students who answered the question incorrectly, and the variance is for the total score. So the variance here is calculated from the total score achieved by each individual student. So the first step for this, to perform the reliability test based on the KR20, is to determine and calculate the total score achieved by each individual student, i.e. adding the score for all the questions answered by each individual student, dividing them by 15, and then multiply that by 100 to get the total or the final mark. So I'm going to decrease the view here so I'll be able to see more of the data. So into the here far right, I'm going to generate a data and in a column label I'm going to call it total score, total S. And to calculate the total mark achieved by each individual, we're going to add all the scores achieved by each student. And the way to do that is to you click on the cell here, then select the sum function, then select the range of the data to input to do the sum, which is the score for all the 15 questions. And then we're going to divide that by the total number of questions, which is 15 questions, and multiply that by 100 to get a percentage. So for the first student, he achieved a 93.3%. So I'm going to decrease the decimal point to 0, and I'm going I'm going also to auto calculate and auto fill the total mark for each individual student. And the way to do that is to hold this cell, select hold, and then drag and then release, and the software will auto fill and auto calculate the value for the final marks or mark achieved by each individual student. Going to center that, make it into the center. So once we have calculated the total score, it is possible to use the equation here and try to determine each part of this equation. So we have already calculated the total score for each participant, so we can calculate the variance for the total scores. So in this cell, I'm going to insert equal sign and then type variance, and then select the variance for samples, as we are using samples here. And then we're going to select the range for the data to calculate the variance for, which is the total score. And if we close the bracket and hit enter, a value of 196 is generated. The next step is to determine the p-value, the q-value, and multiply p by q, and then determine the sum of the p by q. So for p, for each question, the p is the proportion of the student who answered the question correctly, i.e. counting or adding all the correct answer and then dividing them by the total number of the student or the participant. For the first question, select the cell and then select the sum function, and then select the range of the data that we want to sum, and they are in the bracket, and we're going to divide that by 25 as we have 25 students, so to get the proportion. And if you click on enter, a value is generated for question number 1, which is the p-value. To auto-fill and auto-calculate the p for the rest of the items or questions, select the cell, then click on Ctrl+C or copy, whichever options you prefer, and then select the cells that you want to auto-calculate and auto-fill. So I'm going to select the cell below the question number 2, and then hold the control, keep pressing the control key, and then select the rest of the cells up to question number 15. And to auto calculate, right click on the mouse and then select the paste option for formula using a formula found in cell for question number 1. So the p-value now for all the items has been determined. To calculate the Q value, which is for each question, the Q value is the proportion of the student who answered the question wrongly, is just to use the equation of 1 minus the p-value. So in the cell here, I'm going to insert equal sign, then 1 minus, and then select the value of the p, and then hit enter. A value is generated. To autofill and auto calculate the value p, the Q value for all questions, select the cell here by Control C, and then keep pressing the Control key, and then select the cells to autofill and auto calculate the Q value for the 15 questions. Again, right click, choose the paste option for formula. The software will automatically calculate the Q for the rest of the items. Now the next step is to, since we have calculated P and Q, is to multiply P by Q. Again, on this cell, going to insert the equal sign, then select the P value for question number 1, insert the multiplication sign, select the Q value, and then hit the enter key. A value will be generated. So I'm going to reduce the decimal into 2 for this, or using another option, which is formatting cells, number, and then reduce that into, keep it into 2 decimal point. So to autofill and auto calculate the P multiplied by Q for the rest of the items, select the cell and then press the Control and select the rest of the cells to calculate the product of P by Q, and the software will automatically generate the value for each item or questions. Right click, select the formula, and the value will be inserted. The next step is to calculate the sum of all these P multiplied by Q value. In this cell here, we're going to select the sum and then select the value for each item. In this case, Q number 1 to Q number 15. And if you hit the enter key, a value is generated for the sum of all the product of P by Q. So we have now determined the upper part of this equation, the lower part of this equation, and the K is the number, total number of the questions. So the K here is equal to 15. Move this 15 to here. We are now ready to calculate the KR20, and the way to do that is to insert the equal sign and then open a bracket. And since we have 15 questions, we'll divide that by 14, then close the bracket. Once you close the bracket, multiply that. We're going to insert the multiplication and then open another bracket, put the ones number, and then minus the upper part of the equation, which is this one, dividing that by the variance of the total score, which is this one, and then we close the bracket and then we hit the enter key. A value of 1 is generated. So the reliability of this exam based on the KR20 value is determined, and it is found to be equal to 1. What does this mean? If we look at this table here, increase this table a little bit, it shows that when you have a KR20 value above 0.9, the reliability is excellent. So in this case, this exam is extremely reliable, as it is 1. The value for the KR20 is 1. So this is the way to determine the reliability of the test or the exam that consists of multiple choice question using the Coudert-Richardson formula. Another method for calculating and determining the reliability of an exam or a test is to use the Cronbach's alpha formula that is given here. Alpha is equal to k divided by k minus 1, and that is multiplied by 1 minus the sum of the variance for each individual question divided by the total variance or the total score variance. So the k here stands for the total number of questions. We've already calculated the variance for the total score, and we're going to calculate the variance for each individual question. The way to do that is to select this cell and then insert the equal sign and then type variance and select the variance for samples. And we're going to select the range of the data for question number 1 as shown here, and if we hit the enter key, a value is generated. So we're going to reduce the decimal here into 2 decimal. To auto calculate and auto fill and determine the variance for each individual item or question, select the cell here, select, then press Ctrl C, copy, and then keep pressing on the Control key to select the range of the cells to place the value for the variance for each individual question or item for the total 15 questions. Once these cells are selected, right click with the mouse and then select the paste formulas option. A value is generated for each individual question, a value for the variance. Now the next step is to add up all these variance values, and the way to do that is to select the cell here and then select the sum command, and again using the control, pressing the control, select again the cells that contains the values for the variance for for each question one by one up to 15. Once you hit the enter key, a value is generated for the sum of the variance for individual questions. For the variance of the total score, insert the equal sign, then type variance and then select the variance for samples, and then select the range for the data for the total score. A value is generated for the variance of the total score. For the K, the value is 15. Now we have all the part of the equation. The value for those part are already available. So the next step is to calculate the alpha value. Select the cell, insert the equal sign, open a bracket, type 15 divided by 14, close the bracket, insert the multiplication sign, then open another bracket, insert 1, minus sign, and then select the value for the sum of the variance for the items or the question, which is this one, divided by the total score variance, which is this cell. Close the bracket, hit the enter key, a value of 1 is generated. So the reliability value using the Cronbach's alpha formula is 1. This is a very high value that indicates the test is extremely reliable, as shown here by the table. So this is a second method to calculate and determine the reliability of an exam using the Cronbach's alpha approach. And as we can see here that both KR20 and alpha Cronbach's alpha value are similar. The next test in item analysis is the item discrimination. An item discrimination will assess and inspect and investigate each question, multiple choice question, and determine whether that question can distinguish between high performing students and low performing students, and whether the question is a good or bad. And the way to evaluate this is to use the Kelley's equation method given here for the ID, item discrimination, that is equal to upper group minus lower group divided by the 27% of the total students based on their total score. So for this analysis, we need to generate two groups, an upper group that represent the top 27% of the student who had performed extremely well, and a lower group which is the lowest 27% of the students with their grades who had performed the lowest score in the exam, and divide them by 27% of the total number of the students. And to do that, first of all, we need to calculate the total score for each individual student that we had already done. The next step is to rank these scores into descending order from high to low. So if we look at the column that have in it the total score here, we can see here, I'm going to reduce the view. So we have here the total score achieved by each individual participant or students, which is equal to the total mark. The next step is to rank the total score achieved by each student from high to low, and the way to do that is to select the range of the data with the total score with the student numbers. So once the data is highlighted, then we click on the sort and filter option here, select custom sort, a window will appear, and we're going to sort the data by the total score. And we're going to score the order from largest to the smallest, and we're going to keep this box ticked. My data has a header. If we click on OK, the data are sorted from high to low. As we can see here, the student numbers also sorted according to the total score. Once we have determined the rank of the total score for the data, the next step is to generate the upper group and the lower group. So for the upper group, select the cell here, click on the sum, and then select the range of the data. As we are here going to use the formula, which is 27% of the total student, and we have 25 students, so 27% is equal to, if I use a calculator, 27% by, it's equal to approximately 7 students. So in each group we will have 7 students in it. So we are going to select the score based on the total score that is ranked from high to low. We're going to select the first 7 scores achieved by, for the first question achieved by students, and if we hit the enter key, a value of 4 is generated. And to auto calculate and auto fill the upper group for the rest of the items or questions, select the cell, Control C or copy, and then hold the Control key and select the rest of the cells for the remaining questions. And if we hit the enter key, a value is calculated for each individual items. The next step is to calculate and generate the lower group, again based on the similar concept, but now we're going to select the scores for each item for the lower group. Again, we select here the function of the sum, and then we're going to select the lowest 7 score achieved by student for the first item, hit the enter key, a value is generated for the lower group. To auto fill and auto calculate the value for the lower group for the rest of the items, Control C, copy, then press the Control and select the range of the cells to calculate and to auto fill the value for the lower group. And if you hit the enter key, the value is generated for the lower group. So now we have calculated the value for the upper group and then the value for the lower group. The next step is to determine the item discrimination. To calculate the ID value for the first item or question, in this cell, insert the equal sign, open a bracket, select the cell for the upper group, add a minus sign, select the value for the lower group, close the bracket, and since we have selected 7 scores in each group, so we're going to divide that by 7, click on enter, a value has been generated which is equal to 429 for the first item. So the ID or the item discrimination for the first question is equal to 0.29 or 29% if we convert that into percentage. So to auto calculate and auto fill, select this cell and then click on the control and select the rest of the cells to auto calculate the values for the ID for each individual item or question in this data. And if we hit the enter key, a value is generated for each individual item. And if we look here at the table, I'm going to increase the size of the text. You can see here that a value is generated for each individual question. So each individual question is examined and inspected using the ID test. And as we can see, the table here, if the ID equals to from 0 to 0.24, it is a bad question. If it is from 0.25 to 0.39, it's a good item. And if it is from 0.4 to 1, it is extremely excellent item. When it is a negative, then it is a bad item. So when the value for the item is equal to 0, item discrimination, that means the question is not distinguishing between high performing and low performing student. If it is a positive and higher than 0, then that indicates it is discriminating between high and low. For a question that have an ID that have a negative value, that is a bad question, because that means the question is attracting poor student to answer the question correctly, and the high performing student are answering the question wrongly. Again, if we inspect these data here, we can see that, decreasing this a little bit, that for question number 1 it is 0.29. Question number 2 is a good question. Question number 5 is excellent. And here we have question number 7 has a minus value, so this question need to be removed from the exam and replaced. And this question is having a ID value of a 0, so it is not discriminating, so this question need to be replaced. Question number 10 also need to be replaced as it is having a negative value. And for the rest of the test questions, the value need to be compared to this table. So I have color coded these value, and the way to do that is to select the row and then select the conditional formatting, and I'm going to use a new rule. Click on the new rule here, and I'm going to select format cell based on 3 color scales, and I'm going to change the color scale values into numbers for all the 3s. And since we have a value of an ID from 0 to -1, so I'm going to keep the -1 as red labeled, so indicating red. For 0, I'm going to keep it as blank, and for 1 value, which is an excellent question, going to keep it again green. I'll reduce it a little bit. Give that 1, and if you click on OK, again, this is what you get at the end. Each cell is color coded to highlight those questions that they are poor, or those questions that they are bad, and the questions that are 0 here indicate that this question is not discriminating, need to be get rid of it. This question is a poor question because the value for the ID is below what is given here in the table, so this question need to be replaced. So this is the way to determine the ID value for each question and to inspect each question in Excel and to determine whether the question is good or bad or excellent based on the value of the ID using the Kelley's equation. Another way of determining the value for item discrimination is to use a statistical method called point biserial correlation coefficient. The test is based on Pearson's correlation coefficient. The statistical test will examine the relationship between a dichotomous variable, which in this case the item scores or the question scores 0 and 1, correlate that to the total score achieved by the participant in the test. This test will determine a value for the strength of the relationship and the direction of this relationship, whether is it positive or negative, and also will generate a p-value. Student t-test will be used in this calculation. And to perform the test, first of all, we are going to find the correlation association between the dichotomous data and continuous data. The dichotomous data is the scores within an item, 0 or 1, and the continuous data is the scale, the total score achieved by each individual participant. To do this, on this cell, insert the equal sign and then type correlation and select the function of correlation. And to perform the correlation, we are going to have two sets of data, data 1 and data 2. So for data 1, I'm going to correlate the question number 1 scores 0 and 1 with the total scores. So in this formula, I'm going to select the range of the data, add a comma, and then select the second range of a data. In this case is the total scores achieved by participant. And if you close the bracket, and in this case, since we are going to compare each individual question, score of each individual question as highlighted here in the light orange with the total score, I'm going to freeze the total score in this equation. And the way to do that is to click on F4. Once you've done that, press enter key, a value of 0.43 is generated. This value represents the strength of the relationship between the question number 1 and the total score. This relationship is positive, and it does indicate that there is a good relationship between this question and the total score. To auto calculate and auto fill the correlation, calculate the correlation value for the rest of the question or items, I'm going to click on the cell here, click copy it by clicking Ctrl C, and then select the Control key and select the cell you want to calculate the correlation for each of these items. Questions 15 multiple choice questions. Number question 11, 12, and then 14 and 15. And we are going to right click on the mouse and then use the formula paste function. A value is generated for every single item. R value, which is the correlation value. As we can see here, some of these values are in negative, such as question number 7 has a minus value. The others have a positive value. Others have a very weak value of correlation. And if we look at the table associated with that, we can see that a very good item or question has a value of ID that is, or R, that is equal to or greater than 0.4 to 0.7. Anything between 0.25 and 0.4 is considered to be good question. So this question is a good question. This question is a bad question as it has a negative value. What does this value mean? This means that this question is answered by poor student correctly, and the high performing students are answering this question wrongly. So there is something wrong with this question, so it ought to be removed and changed. This question, as it has a high value of correlation, so this is a good question. So anything less than 0.15 value considered to be a very bad question, such as this one, question number 3. So this is the way to determine which question is good, which question is bad, and which question need to be replaced. The next step for the analysis is to try to determine the p-value, significant value for this correlation, whether this correlation is significant or not. And to do that, we're going to use the t-test, the formula given here. T-test equal to the correlation value, Pearson correlation value, the R value, multiplied by the square root of n minus 2 divided by 1 minus the square R in between bracket. The n here stands for the number of participants or students. In this case, there are 25 students. And to use the equation in this cell, insert the equal sign and then insert the R value for the corresponding question or item, and then insert the multiplication sign, open a bracket, and then type square root, and in the square, select the square root. In the square root, we're going to divide n minus 2 over 1 minus r squared. N minus 2 is equal to 23, so 23 divided by, open a bracket, 1 minus r squared. Select the value for the r, insert the symbol here for the square, and then square up to 2, close the bracket, and then we're going to add another bracket for the formula, and then another bracket to seal off the formula. press enter, a value is generated for the t-test comparing the data within the item to the total square. So to auto calculate and auto fill the value for t-test for the rest of the items, Control C, copy, and then select the cells you want to place the formula in. Select Control to select the cells to insert the formula in and to do the calculation for the t-test value for each item in this 15 items. Right click, use the formula, and a value is generated for each individual item that shows the t-test for each question. As we can see here, we have for question number 7 a negative value. To calculate the p-value for each item, we're going to use the following equation. In this cell, insert the equal sign, then type the t-test and select the t-test two ways to determine the p-value. And in this equation, we're going to place the x value for the t-test separated by comma for the degree of freedom, in this case 25 minus 2 equal 23. Before we insert the value of the t-test, I'm going to add a function called absolute to make sure that each value entered in this equation for t-test is a positive value. So if I type absolute and then select the absolute function and then select the x value here is the value for the t-test, close the bracket and then insert a comma and then insert the followed by the degree of freedom, which is 23, close the bracket, hit the enter key. A p value has been generated for the correlation between the item 1 and the total score. To auto fill and auto calculate the p-value for the rest of the items, again select copy and then select the cells to insert and calculate the value for the p-value for the rest of the items, and by selecting the cells for the corresponding items, and then right click and use the paste formula function. And again, as we can see here, a p-value has been generated for each individual item. And we can see from this p-value, anything of a p-value less than 0.05 indicate a significant. So in this case here in the first item, the correlation coefficient value was 0.43 and the significant value is 0.03. So this is a significant, this value here is a significant value as the p value is less than 0.05. So I'm going to type here p is less than 0.05 means that this is significant correlation. So for the first item, the correlation is significant as the p-value is less than 0.05. For question number 2, the value of the correlation is significant For question number 3, the value for the p-value is higher than 0.05, so this correlation is insignificant. For question number 4, the correlation is significant. And as we notice here, for the question number 7, which has a negative correlation, has a p-value of higher than 0.05, so this value is not significant, insignificant, and the rest for this question number 9, the value generated here, that 0.08 for correlation, is not significant. So this is one way to calculate and determine the item discrimination and to determine whether the test is discriminating or not, using the point biserial correlation, using the Pearson correlation coefficient, then calculating the t-test, and from t-test determining the p-value. And based on this, using this table, it is possible to determine which question is good and which question is bad and which question is very good. This is the way to do the point biserial correlation coefficient in Excel for data that are dichotomous for multiple choice question exam, and to determine the quality of the questions. Another test that will examine the item or the question is the item difficulty, that will determine whether an item or a question is difficult or easy. The analysis is based on a calculation formula. Item difficulty equals the total number of the student answered the item correctly divided by the total number of the students multiplied by 100. In our case, we have 25 students. The way to perform item difficulty and calculate and determine the value for the item difficulty is to, in this cell, insert the function of the sum and select the range for the correct answer for a question. Here in this case, question number 1. So we need to add up all the correct answer achieved by the students, and then once this is selected, we're going to divide that by 25 students, as this is the total number of a student, and then multiply that by 100 to get a percentage value. Click on enter. A value of 44% is generated. To auto calculate and auto fill the rest of the value for the rest of the items or questions, select this cell, copy it, and then click on control and then select the rest of the values that you want to determine the ID for the rest of the questions, from question 11, 12, 13, 14, and then 15. And then right click and then use the paste options for formulas. Each individual item have a percentage generated which represent the p-value or the proportion value, which measures the difficulties of the question, whether a question is extremely difficult or extremely easy, as each item has its own item difficulty value. And following the table as a reference and using this table as a reference, we can see here any question that have an item difficulty of a range from 0 to 20 is very difficult. From 21 to 40 is a difficult one. An idealistic item is from 41 to 60, and the question that have a value of item difficulty 61 to 80% is an easy one, and the one that have 81% to 100 is considered to be a very easy question. So we need to target this item difficulty value 41 to 60, as this is the idealistic, a very ideal item or a question. In this case, for question number 1, this is considered to be an ideal question. This one is considered to be a little bit above the ideal question. This one is an ideal question. This one I will consider that as an easy question. This one is an ideal question, and this one is an ideal. This one is an ideal. We'll consider that as an ideal. So the majority of these questions are ideal. If we look at question number 13, the item difficulty is value is very high, so this question is considered to be an easy question, and for the rest are ideal. This one is an ideal question. This is considered to be an easy question. So this is the way to perform item difficulty analysis in Excel, and to determine which question is extremely easy and which question is extremely difficult, using the item difficulty formula linked to the reference table. So far we have performed reliability test for this exam using two different methods: the Couders-Richardson formula, Couders-Richardson 20, and the Cronbach's alpha. And then we looked at the question, each question individually, and examine the quality of each question using the item discrimination analysis based on two methods: the Kelley's equation method and the point biserial correlation. And we had also determined the level of difficulty of each question by performing a item difficulty analysis to determine which question is easy and which question is difficult. In the next section, we're going to perform a distractor analysis. A distractor is the incorrect answer for the multiple choice question. So far we were only looking at the correct answer, the correct option. A distractor is the incorrect option answer or answer option. So for the question number 1, 4 possible options, option A and C and D is considered as a distractor because those are the wrong answer option. And if a student selected these options, then these are the wrong options, and they will contribute into the overall quality of the exam if they follow a certain criteria. To assess and analyze the distractor, we are going to do item distractor analysis based on two methods. The first method is the proportion method. The second one is the item discrimination method, Kelley's method. So for the first method, which is the proportion method, we are going to use the equation given here, which state that the distractor percentage is equal to the number of the students selected the distractor, whether distractor 1 or 2 or 3, in a multiple choice question that have 4 possible options. Divide that by the total number of the students. In our case, it is 25 students. Then multiply that by 100 to get a percentage. And the way to do that is to select this cell, and we are just only going to use this equation for the distractor, not for the correct answer. So for the incorrect answer, in this cell, insert the equal sign and then type count, as we are going to count how many students had selected the first option in the first question. So we're going to select the range from student number 1 to the last student number 25. Then close the bracket, and so what's this count function will only count those values that have in it 0. So we are having here 1 2 3 4 5 6 7 scores, or 7 students had selected this wrong option or answer option or a distractor. We're going to divide that by the total number of the student, which is 25, and then multiply that by 100. If you press the enter key, a percentage or proportion value is generated, 28%. Now, to auto-fill and auto-calculate the value for the distractors for the rest of the questions and also question number 1, copy the cell here, Control C, and then press on the control and select the cells that you want to place the distractor or the proportion, calculate the proportion value for the distractor. Only select the cells that have distractor scores in them. Selecting question 10, distractor 11, and then moving to 12 and to the rest and then selecting this one, and then 14 and 15, selecting the last distractor here. So what we're going to do is right click on the mouse and then use the paste option for formula, and if you click on that, a value is generated for all the distractor, showing the proportion value for each one of these. To color code these values, I'm going to use select the row here, and then use the conditional formatting icon, select highlight cells rules, then scroll down to less than option, and I'm going to color code those cells that have a value in it of less than 5. So I'm going to highlight, I'm going to use the custom format here, and I'm going to change the font of the text into red, and I'm going to make it bold, and I'm going to click on OK. And as we can see here, only those cells that have a proportion value less than 5% are color coded in red. So what does this value mean? For this p-value analysis, for the distractor to be functional and effective, i.e. playing its role into distracting the student from selecting the correct answer and attracting them to select the wrong answer. That is the purpose of the distractor and the analysis of the distractor, to find out how effective, how functional it is in doing its job. which is distracting the student. So any distractor that have a p-value less than 5% is considered to be less effective, non-functional, and anything higher than that is considered to be functional and effective in doing it what it's supposed to do. For distractor number 1, for question number 1, 28%. So this is a good distractor. This is a good distractor as the percentage is above 5%. This is a good distractor. All these are good distractor. They are functioning well in distracting the student from selecting the wrong, from selecting the correct answer and selecting the wrong answer. So for here we notice for question number 11C, only 4% of the students selected this distractor. So this distractor is non-functional, is non-effective, it is useless, so need to be replaced and changed as it's not attracting enough students to select this wrong answer. Again, the same thing for question number 13, option D. You can see here the value is equal to 4%. So this distractor is useless and it needs to be replaced. And any distractor that have a p-value of 0 also considered as useless, non-effective, and needs to be changed or rewritten for an answer option. So this is the way to analyze the distractor and to determine whether a distractor is effective and functional or it is non-functional and it is useless in Excel. Another method for distractor analysis is to use the Kelley equation formula. As given here, the ID equal to upper group minus lower group divided by the 27% of the total students. So the analysis here will only be performed on the distractor, not the correct answer. And for each multiple choice question, there are 3 answer options that are wrong. So we are going to perform an analysis using the Kelley's method in those wrong answer option. And the test is based on ranking the student according to their total score from high to low, and then grouping those students into an upper group and lower group. In the upper group, there will be 27% of the students who had scored highly in the exam. Top 27% of the students scored. And in the lower group, there will be the lowest 27% of the students who had performed poorly in the exam. And the way to do that, as we have done before, is to calculate the total score achieved by each individual participant, as we have done here, then ranking the total score from high to low. Once the rank has been done, the students now are arranged or ranked according to their total score, and then we will be able to or arrange the student into upper group and lower group. Since we have 25 students and 27% out of this will be 7 students, so in the upper group there will be 7 students in it, and in the lower group will be 7 students in it. And what we will do is count how many students had selected the distractor, whether distractor 1 or 2 or 3, i.e. the wrong option, how many times has been selected by those students, and counting this for the upper group, and then also counting how many students had selected the distractor in the lower group. And to do that, we're going to insert in this cell for the first distractor for in the first question to determine the upper group. And to determine the upper group, insert the equal sign and then type count. Click on the count and then select the, since these scores here are in a descending order from high to low, so for the upper group select the first 7 scores for the first distractor, close the bracket, hit the enter key, a value is generated for the first distractor upper group. To autofill and auto-calculate the value for the upper group for the rest of the distractor for each individual item or question, select the value here by Control C and then click the control and then select the cells to insert in them the value for the upper group using a copy and paste option in Excel. So we're going to select each individual distractor for each individual question, and we are not selecting the correct answer, as the analysis only will be for the distractor or the wrong answer option. Once we have selected the range, right click on the mouse, then paste using the formula, and a value has been inserted for each individual distractor. An upper group is generated. For the lower group, again we're going to do the same thing. Select the cell, insert the equal sign, then type count, click on the count, and in this case we are going to select for distractor 1 the lowest 7 students score. So here we have selected 6 and this is 7. Close the bracket and then hit the enter key. A value is generated for the lower group. To autofill and auto-calculate the value for the rest of the distractor, select the cell, Control C, and then to copy it, and then press the control and select the cells or the range of cells that we want to insert the value for the lower group for each distractor within a question or a multiple choice question that have each one of them 3 different distractors. And we need to do this for the rest of the cells, excluding the cell for the correct answer within an item. So we have selected the range. The next step is to right click on the mouse and then click on the format, paste the format of the formula, so the formula is pasted. So now the upper group is determined for each distractor and the lower group is determined. The next step is to determine the item discrimination using the formula given here by subtracting the lower group from the upper group and dividing that by 7, as we have 7 students in each group. So in this cell here we're going to insert the equal sign, then open a bracket, select the first value for the upper group, insert the minus sign, then select the range for the lower group. Here I'm going to type B96, close the bracket, and then we're going to divide that by 7 since we have 7 students in each group. And if we hit the enter key, a minus value of 0.14 is generated. So this is the ID value for this distractor. To auto fill and auto calculate the ID for the rest of the distractor for all the questions, you need to first select this cell, control copy, and then press the control and select the cells that we need to insert in them the ID for each distractor. We're going to do that for all the distractor that we had already wanted to determine the ID value for each, to determine whether these distractors are effective or not based on the Kelley's equation method, and selecting the rest of the cells. Once these cells are selected, right click and use the formula option here. The ID for now all the cells has been determined, and as we can see here, there are some distractor have a 0 value for ID, some have a minus value, and some have a positive value. In the distractor analysis, for a distractor to be functional and effective, it has to attract low performing student to select this wrong option, answer option, or distractor, and to keep attracting those students to select this option. If the distractor has a value of 0, then that means the distractor is not distinguishing between high performing student and low performing student, and both high performing and low performing student are selecting the distractor in equal proportion. So this distractor is not functional, ineffective, such as the Q1C distractor, so it ought to be replaced or changed. A distractor that have a minus value is an effective and a functional distractor because it is attracting low performing student than high performing student, and it does it what it's supposed to do. It does it function by distracting the student. So any distractor that have an ID value of minus is a good effective distractor. Any distractor that have an ID value of 0 or plus is considered to be not effective and non-functional and not useless, and it ought to be replaced or changed. So this distractor here is good one, this one is good, this one is good, this one is a positive. So what does that mean? This distractor is attracting high performing students than low performing student, so it is not a good distractor, so it ought to be replaced. And so this is also for the rest of the analysis, to look at all the distractor ID. Again, this one is minus 43.43. This is a good functional distractor, effective distractor. This is not functional, this is functional, functional, non-functional, non-functional, functional, and so on. So this is the way to do distractor analysis in Excel using the Kelley's equation method to sort out the student into groups, upper group and lower group, and then to get a value. If the value for the ID is negative, then this is a distractor is functional. If it is positive, then it is not functional, and if it is a 0, then also it is an ineffective distractor. In summary, to evaluate and assess the quality of multiple choice question exam, use the item analysis. 4 important analyses can be used in Excel. The first one is the reliability test, using the KR20 and Cronbach's alpha to determine whether the test or an exam is reliable. A second analysis is the item discrimination to determine whether a question is good or bad, whether it can distinguish between high-performing student and low-performing student. The analysis is based on Kelley's equation method and the point biserial correlation coefficient. A third analysis is the item difficulty to determine how difficult and how easy an item or a question in an exam. And finally, to look at and inspect and investigate and check the distractor, and to analyze the distractor and to determine whether the distractor can contribute to the overall quality of the exam by performing an analysis on the proportion of the distractor selected and the item discrimination to determine whether the distractor can distract the student from selecting the correct answer.